Welcome to Research Creations. This video will be covering the topic of trigonometric functions, an integral component of trigonometry. I will be introducing the three fundamental trigonometric functions. Then I will elaborate on how to use those functions to solve for right-angled triangles, sides, and angles. And as a little exercise, I will cap the video off by allowing you to solve a few word problems regarding the topic, followed by an explanation and solutions. Without further ado, let's start by talking about the three trigonometric functions and their principles. The three trigonometric functions are sine, cosine, and tangent. As you can see here, each one has their own symbol and written abbreviation. These three build up the basic functions in trigonometry. The fundamentals you must understand if you want your learning journey to be more fluid when you make headway into the realm of advanced trigonometry, dealing with reciprocal functions and trigonometric identities. Before I move on to explaining what these functions are and how they are applied, I'll lay the foundations by showing you a right-angled triangle. As is common with most right-angled triangles, this triangle has a right angle. Accompanying that exemplary right angle are two other acute angles. I'll label this one on the left as theta. Keep in mind that throughout the video, theta is going to represent angles that are part of a function value. Above theta is the hypotenuse, the longest side of the right-angled triangle. Beside theta is the adjacent side, and across theta is the opposite side. The adjacent and opposite sides are both relative to theta. If we were to move theta to this acute angle on the right, those two sides would swap, with the hypotenuse staying the same. Now, to our first function, sine. Sine is the ratio between a triangle's opposite side to its hypotenuse. If theta is one of the acute angles, the rule that stays constant defines the sine of theta as being equal to the length of the opposite side over the hypotenuse. The second function, cosine, is the ratio between a triangle's adjacent side to its hypotenuse. This provides that the cosine of theta is equal to the length of the adjacent side over the hypotenuse. Tangent, no different from the rest, is the ratio between a triangle's opposite side to its adjacent side. This means that the tangent of theta is always equal to the opposite side over the adjacent side. These functions undeniably require memorization. A linguistically appealing way to do so is by using the mnemonic SOHCAHTOA, shown on screen here, now marked in red. You can see how SO represents the principles of sine, CA represents those of cosine, and TOA of the principles of tangent. So how would you use these functions to solve for a side of a triangle? All you would need to solve for the length of one side is the length of another side, plus the value of angle theta. Let's start off with this example, using sine to solve for the hypotenuse. In this triangle, we are given two values we need in order to solve for length x, theta and the opposite side. According to the principles of sine, the sine of 36.9 degrees would be equal to 3 over x, as represented here. After rearranging the equation to make x the subject, we can calculate 3 over the sine of 36.9, obtaining an x value of 5. Next, in this example of using cosine to solve for the adjacent side, we are given two values that we need in order to solve for length x, theta and the hypotenuse. Abiding by the principles of cosine, the cosine of 36.9 degrees would be equal to x over 5 in this example. By rearranging the equation to make x the subject, we can see that x is equal to 5 times the cosine of 36.9, obtaining an x value of 4. Finally, by using tangent to solve for the opposite side, we are given two values that we need in order to solve for length x, theta and the adjacent side. Like before, the tangent of 36.9 degrees would be equal to x over 4. We can rearrange this equation to make x the subject, and we can calculate x being 4 times the tangent of 36.9, thus getting an x value of 3. The trig functions necessary to solve for angles are slightly different from normal trigonometric functions, and there is this common misconception that I would like to demystify before I move on. Some may see the parentheses theta, or representative, is placed in as a multiplication of the function. And when faced with a known function value, would simply divide that by the function. That just isn't the case. Just like with square numbers, you can't divide it by square to get its square root. Instead, there's this special function called a square root. The same applies to trigonometric functions as well. This leads me to present the three inverse trigonometric functions, whose names respectively have a prefix of arc and are represented by an additional power of -1. These functions are inverse, as the values x and y represent are swapped, as shown on the bottom right, with the angle being equal to the inverse function of the function value, as opposed to the normal trig function, the function value, being equal to the function of the angle. Using our newfound knowledge, let's move on to solving for angles using trigonometric functions. All you would need to solve for one of the acute angles is the length of two sides, starting off with using sine to find angle x. We know that the sine of x is equal to 3/5. Using inverse functions, we can rearrange this equation to make x the subject, as it is equal to the arc sine of 3/5. Punching this into your calculator would get you the x value of 36.9. Next, finding angle x using cosine. The values of the adjacent side and the hypotenuse are given to us. Thus, we can see that the cosine of x is equal to 4/5 in this instance. We can use cosine's inverse to rearrange this equation to make x the subject, as the arc cosine of 4/5 is equal to x, resulting in an x value of 36.9. Lastly, finding angle x using tangent. We have been given the lengths of the adjacent and opposite sides, so we know that the tangent of angle x is equal to 3/4. Using its inverse, we can rearrange this equation to make x the subject, as the arctangent of 3/4 is equal to x, leaving us with a calculated x value of 36.9. I've covered how to solve for sides and angles using trigonometric functions. Now to assess what you've learned, I've prepared 2 questions regarding trigonometric functions and previous topics in the GCSE curriculum. Question 1. Feel free to pause the video at any time and work on this question yourself. Welcome back. We can diagram this question like what you see on screen right now, with the building, tripod, and camera. Then, let's label this diagram with the values that the question has given us, and represent the height of the building as h meters. We know that the camera is 35 meters away, lifted 1 meter above the ground, pointing at an angle of 36 degrees towards the top of the building. Thus, we know that the tangent of 65 degrees is equal to h minus 1 over 35. Then we should rearrange the equation to make h minus 1 the subject, it being equal to 35 times the tangent of 65. From this, h minus 1 would have a value of 75.06, and h would thus be 76.06. The building would be 76.06 meters tall. Moving on to the second question. Again, pause the video whenever if you tend to try this out yourself. We can plot this question on a Cartesian plane just like the question stated. First, let's label down the values the question has given us, and give the angles we have to find their own representatives, color-coded in green and blue here. We know that the laser beam originates from point -14, 10, and reflects at point origin, with its normal line being x equals 0. This can form a right-angled triangle with adjacent and opposite sides with lengths 14 and 10 respectively, both relative to angle x in green. We know that the tangent of angle x is equal to 10/14. We can rearrange this for x to be equal to the arctangent of 10/14. This gets us a value of x as 35.54. To find the angle of incidence, we can minus off 35.54 from 90 degrees to get an angle of incidence of 54.46 degrees. A more straightforward approach would be to find the arctangent of 14/10 directly. Here's a basic run-through of what was covered in this video. The three trigonometric functions, sine, cosine, and tangent, have their own unique principles, which can be memorized through the mnemonic SOHCAHTOA. These align with the properties of a right-angled triangle, with a hypotenuse, along with adjacent and opposite sides both relative to theta. Lastly, use inverse functions when solving for the acute angles in a right-angled triangle.